Here we have our forces simulation. Let's begin with friction. Right now I'm going to turn on all the tools and then briefly explain what each value indicates. The first one, the force arrow, tells you which way the forces go. The second, the sum of forces, tell you where the total applied force goes. The third, the values, tell you the name of the force and how strong it is. The fourth, the masses, tell you the weight of the object. And finally, the speed tells you how fast it goes. Now, I'm going to place a 50 kilogram box on the track and put 500 newtons of pressure to the right. Here we can see the sum of forces are 375 newtons, and that's because the applied force is 500 newtons minus the frictional force of 125 newtons in the opposite direction. The man isn't apparent anymore because the speed became too much for him and he fell off. But besides that, as you can see, the total sum of newtons is 375 newtons to the right, and it gives an acceleration, a great acceleration to the box. Next, I'm going to add another 50 kilogram box to the top of the first box. And I'm going to add another additional 500 newtons of applied force to the right. As you can see, the frictional force got higher because the more mass results in more friction. Next, I'm going to take off one box and use 500 newtons of applied force to the box. Now the 500 newtons of applied force is to the opposite direction, and we can see that the friction is in the same direction until the box starts moving the opposite way. Next, I will get rid of the box and add the present, which gives no mass. I'm once again going to add 500 newtons of applied force to the right. Since there's the same amount of friction and the same amount of the sum of forces, we can indicate that the mass of the present is equal to the mass of the box, which would be 50 kilograms. And that is our forces simulation.